Irodov 1.1. So the question states, a motorboat going downstream overcame a raft at point A. So the important thing to note over here is downstream. Downstream means in the direction of the river. So let us assume that the river is going in this direction with the velocity Vr. So the question states that it overcame a raft at a point A. Let us assume the point over here and let us name it as A. Then tau equal to 60 minutes later it turned back and after some time passed the raft at a distance. It turned back and after some time passed the raft at a distance L equal to 6 kilometers from the point A. So now the raft, which doesn't have an engine, so obviously it will move with the velocity of the river, that is Vr. So it has traversed a distance L, let us name it as B, and it will obviously transverse in the direction of the river. So the raft has gone from point A to point B, and the motorboat, let us assume it starts from here. The question also states that it moves for tau equal to 60 minutes and then returns back. So this is the path of the raft and this is the path of the boat. Then the question says, find the flow velocity assuming the duty of the engine to be constant. So we have to find Vr. And over here is an important point that says assuming the duty of the engine to be constant. That means let us assume that the engine produces such a power that if the river was at rest, the velocity of the boat would be V. But over here we know that the river is moving with the velocity Vr. So when it is traversing a direction, when it is traversing in the direction of the river, that is from t equal to 0 till t equal to tau, we can say that its velocity is equal to V plus Vr. And the distance that is traveled by it, we can say as V plus Vr into the time taken, that is tau. Now it goes against the velocity of the river. So now it has a velocity which is in the opposite direction. It still is going with the velocity V but with minus Vr. So now let us assume that this is the distance D. And it also says that it meets at the point B, that is L distance away from A. So obviously the time taken by the raft to come to point B and the time taken by the boat to come at point B must be the same. But now as we know, the velocity has changed of the boat. So let us assume that it covers this d distance in time t. So we can write d is equal to v minus vr into the time t. And the raft also has moved a distance L but in time t plus tau, because tau is from here till here and t is from here till the distance d. So we can write L is equal to, the raft will move with the velocity of the river, so VR into the total time it has taken, T plus tau. So now we can write that the total distance is equal to D plus L. Now we know the value of D, we know the value of L, we also know the total distance travelled, that is V plus VR tau. V plus VR tau on simplifying it, we will get this equation. Now we can see that VR tau and VR tau will get cut. So we can cut this. VRT and VRT will also get cut. This V over here and this V will also get cut. So now we have got a relation. T is equal to tau. After this relation, we can find out VR. So we already know this equation. If we substitute this value which we just got into this equation, we will get our time. We will get our velocity of the river. So L is equal to VR T tau. Sorry, 2 tau. So VR is equal to L by T tau. We know the value of L, that is 6 kilometers. We know the value of tau, that is 2 into 60 minutes. So I'll take out the answer in kilometers per hour. That would be equal to 2 into 1. That is 3 kilometers per hour. The velocity of the river would be 3 kilometers per hour.